ladies and gentlemen. Now please welcome Dr. Anurag Singh, Associate Professor in CSE Department and formerly Dean RNC and HOD CSE at NIT Delhi. He received his PhD from IIT Kanpur. His research areas are network theory, epidemic modeling, federated learning, machine learning, video captioning, etc. Dr. Anurag Singh has teaching experience at both undergraduate and graduate level. He has taught courses ranging from the introductory level to specialized courses in computer science and engineering. Currently, he is mentoring undergraduate, graduate and PhD students at NIT Delhi. He has approximately 80 publications in leading journals and conferences as well, and completed 2 DST funded projects with one startup. Currently, he is working on a project granted by the Ministry of Earth Sciences and TIH IIT Patna. Let's welcome him with a warm round of applause.
So I am here for taking the session of Introduction to Artificial Intelligence. So this is the slide of Artificial Intelligence, and it is based on material which is shared by following faculty members and researchers. So it is cited initially. So now first question is that who can tell the definition of artificial intelligence? Anyone who can tell what is the definition of artificial intelligence? Or who has gone through the course of artificial intelligence, because some of the students are from first year, second year. Anyone who has completed? One. So do you know this machine, ENIAC machine in 1946? How many of you have you seen this machine? No. So this is the computer which was in 1940s. This is ENIAC. So can you tell me how many computers are there in this picture? 1. It is 1. So now you can assume the size of the computer in that time. So these systems actually used for the numerical computations at that time. Okay. So while we are seeing this picture, so if you please go ahead. So at that time, computer, you can see the form of computer in 1940s, but when artificial intelligence came into the picture, so I think all of you heard the name of Alan Turing. Okay. So with the name of it, there is the award also, Turing Award. So in 1950s, actually he asked the question, can machine think? So now you can, this slide actually tells that when invention has been done, then machine can think also. It was done in 1950s. Okay. So I think all of you know about this Turing experiment. All of you know about it? So in Turing test, at one side there was a person or the person who is deciding, the other side there is machine or human being. So they ask some questions. So the ultimate idea is that how I will say that someone is intelligent or someone can think. So what will be the basic criteria to judge a person that person can think or not? So if I will say that this is a person who can think, so how will you judge? How will you judge? You ask some questions. Questions, those can be answered by a person. So once you will not able to see that the other side is machine or human, and you will ask the question and your answer will, you will get all the desired answer, then definitely it is hard to understand other side machine or computer. So at that time he has done such experiment which was called Turing test, and in 1956 there was the Dartmouth meeting, meeting in the Dartmouth College in August 95. So basically they proposed that 2-month 10-man study of the artificial intelligence. So this was the first meeting where the name artificial intelligence came. Okay. So the term artificial intelligence came in the 1956. So this is just about the evolution. So you can see 50s Turing test, 56 AI born at Dartmouth College, Warsaw, and in 64 a chatbot psychotherapist system has been developed, and it was very efficient system at that time. And 1966 shaky general purpose mobile robot machine has been developed, and you can see the picture of this, which will have lot of sensors, lot of actuators, and definitely they have power for computing and decide many things. So the purpose to show this slide is that artificial intelligence history is not new, it is very old. So this is a very good picture to understand the things. So if you will see this picture, so 3 components are there: data, algorithms, and computation power. Tell me, which one is the oldest among these 3? Algorithms. So we have algorithms with us, which can solve our problem. So now we have enough data also, as we discussed in the last presentation. Enough data we will have. So you can do lot of intelligence thing once you will have data and algorithms. And now you need this third component also, computation power. So if we will have very good enough computation power, then we will definitely able to make very good efficient systems. So these are some examples. So artistic applications, doodle to painting, style transfer, image colorization. I think all of you are aware about this example. There is an example where image or video can be converted into the form of caption. So the purpose to show this slide is that if you will see all the captions, so please see all the captions. Are you finding all the captions are marked correctly? Which one is not? Two hockey players are fighting over the. Okay. So it means it is showing that You have data, you have algorithms, so you are lacking something, so you are not getting the accurate. So efficiency is not 100%. So same captioning can done over the video also. Now we will come over the term definition of AI. So why I am starting from the term definition of AI? Actually, it is very much important to understand the term AI so that you can get the idea how you should proceed further. So as we talk about the physics, so in physics basically we talk about where did the physical universe come from and what laws guide its dynamics. In biology we talk about how did biological life evolve and how do living organisms function. So in case of AI, what is the nature of intelligent thought? Actually, usually if you will ask the question what is the meaning of artificial intelligence, most of the people will try to answer if machine will work like human. So is it the correct definition? So there are two things. Think like a human, act like a human. So which one is correct? And there is two more terms. Think like rational and act like rational. So there are four. There is a 2 cross 2 grid. So I will come over that also. So what is intelligence? Actually it is the very basic idea. If you will go to the dictionary, so all of you see the meaning of a particular term over the dictionary. So if you check the dictionary, then it will show the capacity for learning, reasoning, understanding and similar forms of mental activity. So do you think that that definition is correct? Is it definition? No, it is not the definition. He is trying to tell the intelligence through the example. And last he is stating and similar forms of mental activity. So it is not the definition. So please don't go through the dictionary.com definition for understanding the term intelligence. So what is the intelligence? So ability to perceive and act in the world. Reasoning, providing theorems, medical diagnosis, it should have reasoning. And third is planning, it can take decisions. Learning and adaptation, recommended videos, learn traffic patterns. Understanding, text, speech, visual scene. So right side, whatever is written, you easily can understand many more examples. So all are the examples of an intelligent system. So if I will ask a question, is human intelligent? So what will be the answer? Yes. So try to check all four points are covering for human being. Ability to perceive and act in the world. So best example, how once you will cross the road, then this example you can understand. When you are crossing the road, you are perceiving all the external environment, and after taking the data, you will decide. So one computation will be done in your mind, and accordingly you will act. You should cross the road or not. Okay. Reasoning. Why human is intelligent? Because he has the power of reasoning. Suppose if I will ask some questions, it is not like an objective question. Okay. If objective question will have a line below that, give reason, then you can understand how many marks people will get. So reasoning is not there if you are answering something. So suppose a person will get 80% marks in the objective exam. So can you think that he is intelligent? So what point is missing? Reasoning. Because reasoning is not a sometimes you can answer a question randomly and it will correct, but it doesn't mean your reasoning power is strong. Planning, you can take the various decision. If you want to select some job among the multiple jobs, then you can take the best decision as per your requirement. Learning and adaptation. So you learn from the system and adapt it. Understanding, so text, speech, visual scene, all of the examples by which you can understand it. So intelligence versus human. So are human intelligent? So replicating human behavior, early hallmark of intelligence. Okay. Actually, there is a very good question. What you can imagine a time in past when humans were not there. At that time, was there intelligence?
Yes.
And similarly considered in the future when no human will be there in the world, all will die, then will intelligence exist? So what does it mean for this question? Is intelligence related to the human? Okay, so you should think about it. So are humans always intelligent? Can non-human behavior be intelligent? So we need to answer such questions. So this is the 2x2 grid which covers 4 definitions. So on the column side, human-like and versus rational. See, do you know the difference between human-like and rational? Both are same or different? Why? Who can tell? What is the difference between human-like and rational?
Human can be sometimes biased or something.
Okay. So you are sitting in this workshop. So are you human-like or rational? At that time. Rational. So we will come over that. So you should think about that. At least you should know the difference between these two. Thought versus behavior. So one is thought and one is behavior action, depending over the action. So there are 4 definitions. So I am not going into the detail of the definitions. So 4 definitions are given and it can be categorized under these 4. So you can see first 2. So they are written human thinking, and here faculties through the use of computational model. And here again they are talking about human-like, and again here they are talking about rational. So actually you have to see this part. System that think like humans, system that think rationally. And third is system that act like humans and system that act rationally. All four are the definitions which is given for the AI. Tell me which one is correct according to you. If you look individually, every term will correlate with the artificial intelligence. But can you tell which one is correct?
Think
Think
and
like
act like
humans.
think and act like humans.
So I am hearing the more voice regarding the system that act rationally. Okay, so we will come over that. So most of the people will agree that part is more closer to the definition which we are looking for the artificial intelligence. So this is the Turing test. I am not going into the detail of that. So acting implies thinking. So you will act something when you think. So again you can take the example of crossing the road. So when you think, and you think after perceiving the data from the environment. Okay. So now we also talk about the term weak AI hypothesis versus strong AI hypothesis. So I think all of you clear about the strong and weak AI? Is it clear? So weak hypothesis, machine could act as if they are intelligent. Strong hypothesis, machine that act intelligent have to be think intelligently too. So tell me, your washing machine is supporting weak AI or strong AI? Can you give example of strong AI? Any example of strong AI? So once you are asking expert system, you can consider an expert system. If you will ask the question, he will answer you, and whatever you will asking accordingly, it will update himself also. Okay. So adaptiveness is also there for answering new questions. So this is all about the rational agent. So here, please look carefully this slide. Actually, it tells you which agents are called rational. Because in AI, basically whatever we are doing, basically 3 components are there. Perceiving the data from the outside environment, computation. So that thing will be done by agent. And after doing computation, actuators will perform that acting. Sensors are there for sensing the data. Agents will do computation, and then actuators will perform it. So among these 3, under which component we are working using AI? Sensor, actuators or agent? sensors agent or actuators. And you are making intelligent agent. The term is written. We are trying to make intelligent agent. So rational agent. So please look this term, then you will get all the things will clear to you. So why a person is called rational? Actually, if a person can act and he has multiple actions to do to perform to get some certain goal, then which action he will choose? If you can achieve a goal by doing multiple actions, if you have choice of multiple actions, so which action you will choose for getting the goal?
Most efficient.
Performance. Actually, performance word will come. So if you will read this, an agent should strive to do the right thing based on what it can perceive and the actions it can perform. The right action is to one that will cause the agent to be most successful. So you basically you are having multiple actions and you have to perform one action and that one action will make you successful. So you can take the example of chess. So initially you have multiple options, so you will choose one, and again you will move ahead, and again successor, you will have multiple successor and you will select one better one. Now performance measure, an objective criteria for success of an agent's behavior. So in last workshop I have taken this example. So suppose you are appearing in certain entrance examination. What is your objective at that time? Maximum. For you maximum 100, for me maximum 50. So what should be the objective when once you are appearing in the next entrance exam? You can select it with 1000 rank also. So what is your objective when you are appearing in the entrance exam? Suppose I am appearing in JEE exam. So what is my goal? Think carefully and decide your goal. Na? This is the problem. You should have a certain clear goal. Achha, my objective to get first rank, is it similar to you? My objective to get first rank in an entrance exam.
So analyze the past year's rank and see.
See, otherwise you will never fill the form. Your objective to crack the exam with the first rank. And all person will appear with their full effort. So all person will get rank 1. Yes or no? So are they rational or not? Intelligent or not?
So that's the difference between setting up the objective and the capability to achieve that object.
So the thing is that every person is trying to choose their best action for getting the best reward. So this is the thing. So because of this, it is called rational person. Okay. They will always choose the best action for getting the maximum reward. Okay. So if even you are getting some lesser payoff, it doesn't mean you are not a intelligent person. So performance measure is there, an objective criteria for success of an agent's behavior. So one example is given because there was a robot which used to clean the room. Or you can take the example of vacuum cleaner. So performance measure of my vacuum cleaner agent could be, so for some person can say that amount of dirt cleaned up, some person will say amount of time taken, amount of electricity consumed, some will say that amount of noise generated. Okay, so these could be objective. And what you will try to get, you will try to get maximal objective, try to fulfill maximal objective. So because of this, there is a term, Professor Bapi will tell you about the optimization, constraint optimization. So basically in optimization, you are trying to fulfill multiple constraints. So in that for some people, they will bother about consumption of electricity, so they will give higher weightage to the electricity consumption, lower weightage to the noise. So accordingly, we will make a performance measure function and we will try to get best objective function for that. So this is all about the ideal rational agent. So we already discussed. So finally it is stated that for each possible percept sequence, thus whatever action is expected to maximize its performance measure on the basis of evidence perceived so far and built-in knowledge. So whatever you have perceived so far, and so on the basis of that you will have a set of actions. You will try to maximize your performance measure, and performance measure may be different for different persons. So is it clear what is the meaning of rational? So now you can compare, go and think more about rationality versus omniscience. What is the meaning of omniscience, people? So rationality is similar as omniscience. Why? So what is the meaning of omniscience? Full knowledge. So please now you should start thinking about rationality versus omniscience. So which term we should use here in artificial intelligence? So I am skipping this. So we already discussed about weak and strong AI. So if you will see the recurrent themes of AI during the time, so it starts in 1950s with logic. So initially they are emphasizing over the logic for solving the problems. They are trying to develop the logic for proving a certain theorem. So mainly they are targeting logic. So it is logic dominates. Attempts to extend logic. In 80s, it will become probabilistic. So Bayesian network is the example of this AI. So you should understand the category how it is changing. And in 2000, it is basically neural based. So deep neural networks are there. So it is the powerful representation across modalities. And nowadays, some people are working this neural network with the logic also. So once you will see any book, then initially they will cover this portion, then come to Bayesian network, then come to this part. So usually in AI people will majorly focus over first two components. Second part. Okay. So once we will see, I think all of you are aware with the term search. So why search is become important in the AI? Why search is important in the AI?
To explore all the solutions.
So just take example of the chess game again. Or there is a robot who is cleaning the floor. So in chess game, what actually you are doing, you are on a particular state. Whole chess will have a certain state at that time by putting all the over there. So once you will perform an action, then state will again change. So basically, initially you have multiple options and you need to select one, and after that again you will have multiple successors or fringes and you will select one. So that actually you are moving. So why we are moving from the start state? What is the purpose? To reach the goal. And in any game you know the goal. In chess you want to win, so winning is the goal. In vacuum cleaner robot want to clean the whole floor. So these are the objectives, and accordingly we will move. So now you can understand the term of state. So state means state is a atomic term. State means multiple things are. You can take the chess example. So once a player has chosen any action, then after that whatever you will see the board position, it is called a state. And after some time when one player will select their action, then state will remain same or change. So states are changing. So the idea is that how many states will you have in a problem? It is small or very large? So these large number of states are there. And in this large number of states, you will have some states as a goal state, one state as a start state, and you have to achieve start to goal in the efficient time. Efficiency is the most important part. So why it is called uninformed search? So when you are reaching from the start to goal by using this all the state spaces, it is called state space when you will have all the state, and this size is very large. So there is no ray of light to tell where you have to move further so that in less time you can achieve the goal. So this is uninformed search. So I am not going into the detail about the uninformed search. So basically two uninformed search you know about. Actually it is called brute force search, where there is no guidance, just you will follow a certain method, whether you are getting the solution very near but still you are following a certain method. So this is the various means for agents knowledge representation. So you can propositional logic, relational logic, first order logic, I think all of you are aware with that. And any state is called atomic. Why? Because you cannot see inside the state. So this is one of the example. So you can see, actually it is a robot and this is a dirt in the room. There are two rooms. So in first state, robot was in the first room. In second state, so you can see all the part, and this is the basically goal because there is no dirt. And other states are intermediate state. It is also a goal state. I told you goal state may be multiple. So accordingly you can define the atomic. So all the states are atomic. And accordingly proposition you can define dirt in left room, dirt in right room. You know how to write the logic. I assume that you know about the propositional logic. So same problem can be written in that form. And you can also relate the relation here also. So in this way we can define the state. So once you will have state, then these problems can become a search problem. So these are the inputs and outputs in the case of search. So I am directly coming over that so you can see states, actions, goal test, path test. So states are this is the 8 puzzle game, all of you are aware with that. So you have to arrange all the digits and at back side you will get a picture once you will arrange all the things. Location of tiles. So tell me how many states are there? 2 or 8? So this is called one state. When you shuffle one tile, then it will become the next state. So now you can assume the complete tree from the start to goal. So tell me after this how many states are possible? After this how many states will be possible? Start state. 4. Okay. And after this how many states are possible? 2. So it depends. And among that you have to choose which one give you the best result. But in the uninformed search there is a no way. If you are following depth first, you should consider depth first. If you are choosing breadth first, then you have to consider breadth first. And what are the actions? So these 4 components you should know for every problem. Actions will be any tiles can be blank. It can move right, up, down. So you can write in any way. So it depends upon the problem by which you are defining. Goal test means every time you will check a state, is it goal or not? This is called goal test. Suppose you have moved some tile and you will reach to the next state, then again you will test with the goal. So in that case, which is given? So goal state is given. So goal state will help you to do the goal test. And path cost. Suppose you are shifting the tile, so for simplicity it is assuming, so every movement will have a uniform cost. So again you know the cost if you are moving in the tree or graph, so some cost will be higher and some cost will be lower, and you have to search about the optimal cost. So this is the example, so I am not going into the detail of this. So how a search algorithm will be computed? So completeness, one example. Completeness means, will this algorithm give the solution or not? So if any algorithm is able to give the solution, then it is called complete. Time complexity, number of nodes generated. So every time successors are generated. So the number of successors generated from the every state, and that generated node will lead the time complexity. What is the space complexity? So you can assume any search method, breadth first or depth first. Once you will move ahead, like that first search, suppose you are moving ahead in depth. After some time when you will not get the solution, what will you do? Get backtrack. So in backtrack, you should have previous node into the memory. So, but in the depth first search, you need not to store all the nodes which are coming into the bed. So how many nodes you are storing into the memory? So that will take care about the space complexity. Optimality, does it always find a least cost solution? And systematicity is also the important criteria. It will tell you, does it visit each state at most once? Then it is called systematic search. Okay. So by choosing B as a maximum branching factor means each state can generate maximum number of successors are B. B is the depth of least cost solution. The level at which you are getting the least cost solution, that depth is D. And M is the maximum depth of the state space. In some search, you may have infinite also. Yeah. So uninformed search are there. So you have heard about breadth first search and depth first search. So there are two more search, depth limited and iterative deepening. So depth limited means you are using depth first search, but you limit. I will not go beyond the depth 2 or depth 3. So that is called depth limited. And iterative deepening search is always you will define the deepness factor, and iteratively you will go from 1 to that depth. So if you will see the complexity, so depth first search completeness is no. Can anyone tell why it is not complete search? DFS, why is not complete? Because M can be infinite, depth can be infinite. So this is the breadth first search. So why we are talking about complexity of very simple algorithms, so that in next step we will try to improve this complexity. Otherwise, for large state space, machine cannot compute the things in time. So you can see with the depth 2, 4, 6, how computation time is increasing and how number of nodes are increasing. So if you will have depth 16, node will be this and time taken by 350 years. Okay. So he has considered execution of 1000 bytes per node, then this time will be taken. So definitely we need improvement. So they use beam search. Beam search you will focus over the beam part only, but again it is the uninformed search. This is iterative deepening. Every time you will decide the depth and do the iteration every time. So it can reduce the complexity, but still it is not very effective. So once iterative deepening means every time you will fix like depth 5, then you will start from 1, 2, 3, 4, 5 depth. And once you fix depth 6, then again it will start from 1 to 6. So it is trying to showing that if you will increasing the depth parameter, so the ratio, actually if you are increasing the depth and it is happening iteratively, it is trying to show that it will not affect more. Iterative will not affect more. So this is forward and backward. So forward backward means if there is a solution, there is a start, there is a goal, then you can move from both sides. So definitely it will reduce half of the search. It's called bidirectional. So bidirectional search will also improve the complexity. It will become d by 2, b to the power d by 2. So this is comparison of all the uninformed search algorithms. So now we will see something about informed search. Can anyone tell the name of any informed search? A-star informed search. So informed search which can help you to get the solution with the less complexity. So here you can see this is the goal, this is the start, and there are 3 successor of it. This So someone can guide that you should choose this node. So what they will do, they will put some evaluation function for all the nodes. So we will calculate some function value for all the nodes, and on the basis of that evaluation function value, you can choose the next one. So actually blind search, uninformed search, brute force search, you can tell any name, versus informed search. So our node is selected for expansion based on evaluation function that estimate cost to goal. But in the uninformed search, it was not present. So I am not going into the algorithm. So just talk about one search which is called best first search. So just better to come. Okay. So there is greedy best first search. So the function which will help you to guide to choose the best node so that you can reach over the goal without having higher time or space complexity, that is called heuristic function. Okay. So heuristic function is the estimate of cost from end to goal. So tell me, it is the a priori function or posteriori function? Heuristic function a priori or posteriori? Okay. It is not a priori. So if you are currently lying over a node N, so how much cost you have to spend to the goal? So that is called heuristic function. And there is one more cost. If you are at N, how much you have spent the cost from the start node? So there are two costs if you are at N node. One is past and one is a posteriori. So here, actually in this example, he has chosen the straight line distance. Straight line distance means who is nearer to this. So you just take the straight line distance, so which will be the nearer. So it will be seen from the straight line distance. So heuristic function for straight line distance, if you are at node N, it is N to Bucharest. Bucharest is given because it is a goal. So if Bucharest is the goal, so what will be the heuristic function? So if you are at N, so what will be the distance from N to Bucharest? So in this case, greedy best first search, you need to calculate always heuristic function. So I am coming to directly this example why A star algorithm is used. So just take this example from this place. Can you see this? This node. So suppose you have to go from this node to this node or RDR. So tell me from here, if it is the start state, so which node you will choose? So how many successors of this node? 2, Neymar and Vasulail. So which one is nearer? Neymar. So you will go to the Neymar. And from Neymar, which is the node which is what is the successor from the Neymar? Acha, why you have chosen Neymar? Because you are seeing how far it is from goal. So among these two, who is far from the goal? Vasulail. Why? Because you are considering the straight line distance. Because of this, he has written straight line distance. If you take the straight line distance, it is nearer. So once you are here, then who is the successor? This one. So where you will reach? This. And what will happen at this point? Again, so you will move between Neymar and this node. So can you reach over the goal? It is not complete. So what could be the solution? So what is missing here? Missing part is that we are not considering the cost from the starting to the current node. How much cost you are spending to reach over that node. See, in the second cycle, Neymar will have the cost. If you will consider the cost from start, it is 87 plus 87. In third time, it is 87 plus 87 plus 87. So if you will consider this cost, then you will never go in that direction. Where you will go? In that direction. So what part is missing? So you are considering the cost from current node to the goal, but you are not considering the cost for reaching to the current node from the start node. So if you take both, then it will become the A star search. Okay. So in A star search, you will calculate the evaluation function by choosing both. So Gn is called cost so far to reach N, and Hn is the estimated cost from N to goal. So this is the example, easily you can understand. So So now I am trying to discuss the local search optimization algorithm. So local search basically, so there are two terms, satisfaction versus optimization. So can you tell that both are same term or different? Satisfaction and optimization.
No, sir, different.
Different. So goal satisfaction reach the goal node constraint satisfaction. Constraint means, see, I think all of you can understand the optimization problem, how it is written. And how you should write the optimization problem? You know the meaning of optimization? See, the thing is that suppose, so what is your objective nowadays? So most of the people will have objective to earn the more money. Yeah? So how can you earn more money? What should be your actions? What are the parameters which will help you to earn more money?
Saving and research.
You can take one, how many hours you are spending in the day, or study, learn the new things. Suppose there are certain parameters, 3-4 parameters which will help you to earn more money. See, for earning the money you should have some skills, na? You should do something. So consider that thing as a parameter. So suppose this is the parameter that you have to work these number of hours in a day. So that should be maximum. Suppose this is the amount which you can earn, and that function depends upon this parameter, and it should be. See, it could in some case if you are considering loss function, then it should be minimum. So it depends. So that is called objective function. No? So this is your objective function which depends upon the multiple parameters. So what we are trying to do, we are trying to fix the values of this parameter so that you will get the maximum value. So you can say that put h is equal to 24 hours. Then definitely 24 hours will give you the maximum value if you will work for 24 hours. But is it possible? Eh? No. So definitely each parameters will have certain constraints. Okay. So actually we are trying to maximize or minimize our objective on the basis of constraints. So three components are there for optimization problem: this objective function, constraints, one more thing, how many decision parameters which are affecting. So you should write decision parameter. So ultimately after solving the optimization, you will get the optimal values of those parameters. If you will fill that, then you will get the maximum value by satisfying the constraints. So local search so goal is reach the goal node constraint satisfaction. So is it related to the optimization? Now see this part. Is it related to the optimization? Reach the goal node by using constraint satisfaction. So you will have multiple constraints. On satisfying those constraints, you are reaching over the goal. Okay. And optimization, optimize the objective function, constraint optimization. Actually, you may have multiple objective function also. Suppose you need to get higher money. Second, as I told you, you should get maximum fame also. you should spend less time also. So you have multiple objective function also. So you can go back and forth between the two problems typically in the same complexity class basically. So local search algorithms basically keep track of single current state and we try to move the neighboring state. So once you will go into the neighboring state, then you can ignore the other path. So can anyone tell why ignoring the path will help us? Which complexity will be reduced if we will ignore the paths and we will go into the neighboring state only? Time or space? Eh? Space. Space complexity. So advantage, use very little memory. Can often find reasonable solution, pure optimization problem. These are the all states have an objective function like that. So every state will be an objective function in this case. So this is the example of a n-queue problem where you have to place the n-queue in a certain manner. So you are moving by satisfying, every state will have certain constraint. So every time you are moving ahead after satisfying the constraint and at last you will satisfy all the constraint, that will be your solution. Because that queue should not be in the attacking position. So this is the example by which you can understand. So basically he is trying to move some algorithm which is again heuristic algorithm called local search space, and it is hill climbing. So once you climb over the hill, what you will do? So once you are here, you will choose your successor, choose best one, then go ahead and upside. So once you will reach over the top, then you will realize after that you are losing your evaluation function, so you will never go down. Okay. So always you are going in the direction, in one direction. So tell me, the method which I told you, hill climbing, when you are climbing over the hill. Climbing over the hill means, suppose you have multiple states, multiple successors from a state, you are selecting neighboring state and discarding other. So it means it is like climbing over the hill, not coming down. So after that again you are choosing the best, again you are climbing the hill. You are ignoring the others. So after some time you will get the top of the hill, because after that evaluation function will give you the maximum value. So after climbing the hill, is it the example of global solution or local solution?
Local solution.
Local solution, because there may be the another hill which is on the peak. So in this case there are certain problem you cannot, so once you are over the top, then how will you go on the other top? So they provided some solutions for that. So there are some methods which you need to understand. Random sampling. So in the random sampling you can generate any state randomly. So what will happen? So maybe sometime you will on the other hill. So maybe that hill will give you the best solution. Okay. And another is random walk. Random walk means, just try to understand, suppose I am here and I am going in that direction, because hill is like that. Sorry, not hill. So I am climbing the hill and we are going in that direction. So suppose I am here, so where I will go next after applying hill climbing algorithm? Up and then up. So tell me, it is random walk or not? What is random walk? Random walk means from one place you will have probability to go in all the available paths. You can go here, you can go here. Suppose you have 4 paths, then there is a probability, then you can go all the possible 4 paths. But in this case, what is happening? Whatever example I am telling you in hill climbing, is it random walk? Because there is one probability only. So if you will apply random walk, then what will happen? There is some probability to go down also. So what will happen? Then you can go to the other hill also. So there is a solution, choose the random walk, give a small probability for go down. If you will select that and you will go down, once you will are here, then again try to up the next hill. So there are random sampling, choose any state randomly, so you will be anywhere, maybe next hill climbing situation. Randomly pick a neighbor of the current state. Both algorithms asymptotically complete. So hill climbing will have certain issues. Easily you can say that you may have shoulder means you are having the not here best solution, but after some time you will get best solution. Suppose you are searching here, but you always feel that. So after some time you will search, you will think that all times you are getting the same solution. Maybe you will stop yourself, but after some time you will get a best solution. So this is local maximum, global maximum, flat local maximum. So you can see the various terminology over that. So hill climbing can reduce the efficiency for many problems, and it has problem of local maxima, plateaus, diagonal ridges. So you can see as per after it, I think you are aware with these three terms. So taboo search is also one of the example. Taboo search is as taboo means you will create a list of nodes, and that will call taboo list. Taboo list is like that. Suppose you are at flat shoulder, and you are applying a random walk. So you are go ahead and come back. So what may happen? Some nodes are visited multiple times. So to get rid of that thing, if any node is visited, you should to put that node into the taboo list, okay? And you can avoid that. So actually it is the example of local search. So again he is telling hill climbing with random walk. So you can understand random walk, you have certain probability to go down also. Actually Google PageRank also use certain methods for improving the PageRank algorithm by using the damping factor. You know about that? So this is all about the local search algorithm. So just there is a last portion which I want to tell you about the probabilistic probability models, because after that in next presentation they will open this. Okay, so I think all of you are aware with the adversarial search, because in the search which we are discussing till now, only one player is moving the direction in one direction, but here you may have multiple players in any game. So if you are maximizing your objective by choosing any action and go to the next state, other player will also maximizing their objective. So in that case, it is called maximum minimum problem. As a player 1, you are maximizing your objective, and player 2 is minimizing your objective. So max min problem is there. So mainly games of strategy with the following characteristics: sequence of moves, possible moves, rules that specify a payment for each move. So how much payoff you will get by that move. Objective is to maximize your payoff. So unpredictable opponent you will have, and time limits are also there to find the goal. Okay, so you can see this example for this why how adversarial search will here. So recently searches is moving in one direction by assuming that it is played by only one person, but now in adversarial search you will have opponent also. So if you will see this example, in this game one person will put cross and one person will put 0. So there are two persons. So he will choose one of the possible action to maximize his payoff, and this player and the second player basically, what second player will do? He will choose a action. Second player here, he will choose a action. What will be the objective of the second player here? To minimize the payoff of the other. So instead of it is called max problem, it is called min-max or max-min problem. So accordingly, they have certain algorithms, but later it is realized about the complexity. There is some lacking in the complexity. So this is the example only. So how it is moving. So actually at the bottom you will have the values 80, 30. This. So if it is a maxima move, so what will happen is this among 80, 30, minimum will choose the minimum one. And again maxima will appear, so it will choose the maximum. So accordingly it will go. So initially these payoffs are given, accordingly you can fill on. So this algorithm will work like that. So what found here, this algorithm complexity, so it is optimal, yes, against an optimal opponent, but no, does not exploit opponent weakness against suboptimal opponent. And time complexity is order b to the power n. So is it higher or lower? Higher. Still it is higher. So to improve the complexity, actually he has calculated some complexity and he found that it is time taken is very high. So what he is trying to do, they try to prune some nodes. So if some nodes are pruned, then that will be not be traversed and complexity can be reduced. So I am not going in the details. So that is called alpha beta pruning. So the method is there for alpha beta pruning. So by doing this, you can reduce the complexity. Okay. So the objective is that whatever we have discussed, so what is the basic meaning of AI? And I told you it comes under three adjective themes. One is logic, second is probabilistic model, third is neural net. So again, if we will talk about the probabilistic model, then we will talk about some Bayesian networks. So the objective of Bayesian network to identify a node so that we have this probabilistic. So what I will do, actually we are lacking in time, Professor Bapi is also waiting. So in between sometime I will discuss actually we need not to discuss the third component because it will be covered there. So Bayesian or probabilistic model I will cover in some next session. It will take 25 minutes. So I am ending here only so that we can compromise our time. So some other time I will continue my lecture. So thank you for your patience. And if you have any questions, you can ask before closing. Any questions you have? So actually you should have enough knowledge about the artificial intelligence so that you can get the idea how to make your agent intelligent. So what are the various search methods? What are the local search? What are the adversarial search? How Bayesian network will help in that? What is the constraint satisfaction problem? Because some problems can be written in terms of CSP also. So, okay, so we will meet in some other lecture. Thank you. We will go for lunch, and after lunch, Professor Bapi will continue with this call. And tomorrow
So now it's lunch time. All of you can go to first room for the lunch. Thank you.